Here are some examples from day 27 and where we're factoring. And here they want us to factor this polynomial. This is a cubic trinomial. It's to the third power, and there's three terms. And I see that they all have a common factor. All of these can be divided by x. So the first thing I'm going to do is I'm going to factor out that x, and that leaves me x squared plus x minus 6. But I want to factor completely. So that x squared minus x plus x minus 6 could possibly be factored further. 1 times negative 6 is negative 6. And in the middle, we have a 1 in front. So are there two numbers that multiply to give you negative 6 that add up to 1? Well, 1 and 6 is 6, 2 and 3 is 6. And if I were to make this 2 negative and the 3 positive, that would give me 1. Since my lead number was 1, I still have the x from the greatest common factor, but now I can just say x minus 2 and x plus 3. Factor this polynomial or identify it as irreducible. So here I have two terms. These do not have a common factor, but if it's a sum, if I could rewrite it as a sum of cubes, then I would be able to factor. Now, x to the third is a perfect cube, but 9 would also have to be a perfect cube. But no, if I take the cube root of 9, it's an irrational number. 9 is a perfect square, but it's not a perfect cube. So this actually cannot be factored, which on the notes we called prime. This book calls it irreducible. I haven't heard that before, but I guess either one would suffice, and they want me to enter NA. That's what I'll put in, and that's correct. So, okay, here, two terms. Here there is no common factor, but this can be rewritten as a difference of cubes. This is x to the third minus 6 to the third. 6 to the third power is 216. So now all I have to do is substitute. On a difference of cubes, I know that my first factor is going to be just the same two terms written, but without the exponents. And since I've already used the negative, you're only allowed one negative in factored form. I've already used it. I know that all my terms on this next polynomial are going to be positive. And it's the first term times itself, so that x times x is x squared. Then times each other, 6 times x is 6x, and then 6 times 6 at the end is 36. And that second polynomial, even though it's quadratic, that will never be able to be factored. So x minus 6, x squared plus 6x plus 36. Factor this polynomial or identify it as irreducible. So 432 and 250, well, those are both even numbers. So I know that they can both be at least divided by 2. The question is, can they be divided by anything else? And I don't believe they can. So if I factor out the 2 first, that would leave me 216x to the third plus 125. And actually, both of those are perfect cubes. So if I wanted to rewrite that, 216x to the third is the same thing as saying 6x to the third power plus 125 is the same as saying 5 to the third power. So now this just becomes substitution. I have the 2 that I had originally. My first factor is just going to be the terms written but without the cubes, so 6x plus 5. Since I haven't used my negative yet, I know that my middle term is going to be negative in this next parentheses. The first term is going to be the first term that's being cubed times itself, so 6x times 6x is 36x squared. Then I have to use that minus. 6x times 5 is 30x. And then finally, 5 times 5 is going to be plus 25. That last trinomial will never be able to be factored. So 2 parentheses 6x plus 5. And then 36x squared minus 30x plus 25. Factor this polynomial or identify it as irreducible. So this is a fourth degree trinomial. We do have a common factor. I can factor out an x squared here. That leaves me 2x squared plus 7x plus 5. So the question is here, if I can factor this further, it would be because 2 times 5, which is 10, and the middle is 7. So I'd have to come up with two numbers that multiply to give me 10 and add up to 7. And that can happen with a positive 2 and a positive 5. Now, because the lead in here, though, is not 1, it's 2, that means that I'm going to have to either split the middle term and group or use the shortcut. I'll just use the shortcut I showed you, which is to go ahead and write the x plus 2 and the x plus 5, but leave space so that you can put this 2 that was in front of both of them. Now, if they have any common factors, you would just cancel it out. So here these can be divided by 2. Nothing else can happen with the 2x plus 5. So I have the x squared. This becomes x plus 1, and 2x plus 5 stays the same. Factor this polynomial by grouping. Okay, so here we have 4 terms. This is a cubic polynomial of 4 terms. So if I were to put them in groups, the first two have an x squared in common, which would, if I divided each one by x squared, I would get x plus 8. And the second two don't appear to have anything in common, but I'm trying to get it to look like x plus 8, and I see a negative x and a negative 8. So if I were to factor out a negative 1, divide each one by negative 1, that would give me the x plus 8. So groups can be factored as inside, which is x plus 8, times outside, which is x squared minus 1. In many instances, I'd be done, but this x squared minus 1 is a difference of squares, which we know already from before that can be factored as conjugates. So I have x plus 8, x plus 1, and x minus 1. Those are conjugates. Okay, the last one, factor by grouping. First, I look for a common factor with all 4 terms, but they don't all have something in common. So the first two have a 64x to the third in common. They can both be divided by 64x to the third, which leaves me x plus 1. The second two can both be divided by 125, which leaves me an x plus 1. So the groups would then be x plus 1 and then 64x to the third plus 125. But that 64x to the third plus 125 can still be factored further because that is a sum of cubes. So 64x to the third is the same thing as saying 4x cubed, and 125 is the same thing as saying 5 cubed. So now by substitution, I still have the x plus 1 out in front. Then my first factor is just going to be the same terms, but without the powers, without the cubes, so 4x plus 5. Since I haven't used my negative, my middle term in this second factor is going to be negative. So the first one, 4x times 4x, is 16x squared. Then the negative, 4x times 5 is 20x. And then finally, 5 times 5 is 25.